Hey, what is up mga beasts? So we're back for another video at pag-uusapan naman natin ngayon na tungkol sa deflection of beams. Let's go! Alright, so kamusta kami lahat? I'm back, no? Biglang gumana yung utak ko at tignan natin kung saan tayo dadalhin ng motivation na to. Baka magtuloy-tuloy, di ba? So yeah, so our topic would be deflection of beams. As I said a while ago, no? Deflection of beams, deflection, just a short discussion, is the movement, no? So, mula sa original position ng isang beam. Kunwari, di ba, kapag meron tayong beam dito, and let's say may load dyan, kunwari, naglanding si Spider-Man dyan, pew pew, kagaling yung sapot dyan, tapos po, naglanding siya dyan. May load dyan, di ba guys? May load na pababa, and we expect that our beam would have a certain movement. Mag-bend siyang parang pagkaran, di ba? It will not stay as rigid as it is, right? So, that movement, specifically the vertical movement from its original position papunta kung saan man siya nag-bend or what, that is what we call the deflection, no? So, we are solving for this distance, okay? So, bakit natin sinosolve yan? Well, we will use it in design, alright? So, kailangan nating ma-solve kasi there are certain beams, certain structures that requires only the deflection should be at this minimum. So, hindi ka dapat tataas sa deflection yan because it will cause failure at all. Okay? So, let's go to the methods. Paano natin solve yung distance na to? Okay? So, there are a lot of methods actually, no? We have, ito yung unahin natin, double integration method. Meron tayong area moment method, Castellanos, virtual work, ang dami guys, no? Pero dito muna tayo. This is like the basic, I think, no? And pinaka-common na ginagamit. Medyo mahaba yung solution, pero let's start first with the long cut, right? So this, let's start with the double integration method. So ano ba yung concept nitong double integration method, guys? So we have this formula, no, which is the second derivative of y with respect to x, or the dy dx squared, tama ba? Second derivative of y with respect to x is equal to m over ei. So, if we will simplify this equation, we will just say the second derivative of y is equal to m over ei. Now, ano itong mga variables na ito? Itong m, ei, and itong y. Alright? So, simulan natin dito. Ang ating e, guys, is our, if I'm not mistaken, sorry. Nakalimutan ko na ito. This is the modulus of elasticity, right? Modulus of elasticity. And our I is the moment of inertia. So, itong moment of inertia, it will vary. Depende sa cross-section, right? So, most of the times naman, given itong E and I. Alright? So, in most problems that you will encounter, these are all given. But, if it's not given, well, you could solve it, no? Basta given yung dimensions ng cross-section. Sometimes, ibang mga problem, yung given is the flexural rigidity. Kapag yun yung given, it's just the same as EI. EI, the product of EI is equal to flexural rigidity. So, if that's the given, well, EI na yan. Okay? So, next, ano itong M? Now, this M, mga bis, is the moment equation in terms of X. Okay? So, M is the moment equation in terms of X. So, we will deal with that later. Mas maintindihan natin yan. How can we solve for the moment of moment equation in terms of X. And lastly, Y. This variable Y is the vertical deflection. And the variable X, ito nga, will be the horizontal distance. Yeah. Mas maintindihan nyo yan kapag may example na tayo. Okay, so balik tayo dito sa M. How are we going to determine the moment equation in terms of X? So, let's say we have here a simply supported beam. Kunwari, ito. Yan. Ang galing ko pa rin mag-drawing, Ayun. Tapos, siguro sabihin natin naka-roller yon, tapos naka-pin. Now, let's say we have here a certain point load. Yan. And we have here a uniformly distributed load. Okay? Yan. Sabihin natin na yung point load natin is 5 units. Okay? And then, ito will be 2 units. Okay? Yung magnitude niya. 2 units per units. Lagyan nga natin ng kilonewton yan. 2 kilonewton per meter. And let's say, this total distance is, ano yung favorite number ko? 10. Hindi ko favorite number yan. Isip ko lang. So, ayan. Kunwari ito yung beam natin, mga bees, no? And, to solve for deflection, of course, kailangan nating mahanap yung mga to, no? Say, given na yung E and I, no problem with that. Itong M, we need to solve for that, which is the moment equation nga, no? So, how will that be done? So, paano natin yan gagawin? First, kailangan nating putulin to, diba? So, imaginary lang, no? Kinidlatan ni Victor Magtanggol. Yan, nakidlatan to, tapos putulin natin to. So, saan ba natin puputulin? Puputulin natin yung mga bees doon sa rightmost, just before the right support, tama ba? Yeah, just before the right support. And make sure, mga bees, no, that lahat ng mga loadings ay na-include sa left part dito. Okay? So, dito, kahit pwedeng din yan putulin, it doesn't matter. We will set this distance as x. Okay? Basta yung ayun nga, concept, rule, I don't know, better rule, concept, any sa dalawang yan, is dapat na-include yung mga to. Okay? So, kunwari, meron tayo ditong concentrated moment, wag mong puputulin dito. Dapat included pa rin to. Okay? So, dito mo iputol para included lahat sila sa bang here or sa left side. So, how if, kunwari, let's say, meron tayo ditong distributed load hanggang sa dulo, pag puputulin natin to, hindi natin pwedeng ma-include yung part na to. Okay lang yun, mga bis, no? Kapag meron tayong distributed load dito, okay lang, putulin natin dito, but at least, included pa rin yung part ng, ma-included pa rin na part ng distributed load na to. Okay? So, don't forget that. Now, erase ko lang to. Yun. So, now, erase natin to para hindi maging komplikado. Ayan. Okay, now mga bees, let us draw this cut section. Okay, so yan, drawing natin. Bang, bang, bang. So, kunwari naputol yun, this M, mga bees, would be the moment, no? Moment with respect dito sa ating cut section. Parang ito yung magiging reference point mo if you will solve for this M or the moment equation. Now, nang pinutol natin yan, pinutol lang natin yan at any given point, right? So, we don't know kung saan natin pinutol yan. Therefore, this distance, we will set that as the distance x. Kung ano yung distance ng left section na yun, you will always set that as x. Okay? So, no matter what. Now, tignan natin. I-project natin yung mga loading na to. Okay? So, meron tayo ditong point load. Meron din tayo ditong UDL, right? Ayan. Tapos, take note, mga bees, meron tayong support reaction dito. So, before you can proceed here, dapat masolve mo muna pala yung mga reactions, right? So, ayan. Meron tayong R reaction yan. So, let's say that is reaction A, RA, force RA, right? Now, how will we do that? How will we solve for the moment equation? Of course, basics lang. Clockwise rotations would be positive, counterclockwise would be negative. So, RA, the force RA will create a clockwise movement, diba? Kasi ikot siya nagpaganon. Remember, this is our pivot point. So, ikot siya nagpaganon, positive. Okay, so positive yun multiplied by the perpendicular distance, which is x. So, RA times x, diba? So, tuloy natin. Ito, let's say this is 2 kilonewton per meter, diba? Kilonewton per meter. Okay, so this 2 kilonewton per meter, of course, we need to convert that first sa point load, diba? So, ano ba yung converted point load niyan? That would be 2 times, kulang yung given. Let's say it is this UDL is acting on 2 meter length. Let's say 2 meters yung pinag-aakan niya sa beam. So, that would be 2 times 2 would be 4 kilonewtons. Kasi UDL nga, convert lang natin yung rectangular load into a point load. So, negative 4 kilonewton. Kasi negative because it will create counterclockwise, right? Ikot siya ng pag ganon. Diba? Clock counter, diba? O, tama. Now, ano ngayon yung distance niya mula dito sa center ng UDL papunta sa ating reference or pivot point? So, that would be 2. So, mag-ibig sabihin, yung ito, magiging 1. Okay? Or ito, 1 rin. Kasi rectangle lang naman. Kaya sentro-sentro yan eh. Now, to that distance, mula dito, papunta dito, would be, this distance, mga bis, is x, yung total, minus yung 1. So, this would be x minus 1. So, that perpendicular distance would be equal to x minus 1. And continuing with our problem, no? Meron din tayo yung point load. Let's say, our point load here is 5 kilonewton, yun nga. So, next, same then, counterclockwise, yung i-create niyang moment. So, negative 5 multiplied sa distance, pumunta sa ating pivot point. Now, ano yung distance niya? That would be equal to x minus, let's say, this distance, mula sa 5 na to, papunta sa, dito is a. Let's say that's a, okay? So, that's x minus a would be this distance, right? So, this remaining distance here would be x minus a times x minus a. Okay, so ginawa ko ng variable beyond to do some explanation after all. Okay, so with this, ito na yung ating m or the moment equation in terms of x. So, don't forget that, mga bis, no? First rule, putulin. Okay, putulin nyo na dapat naka-include lahat sa left section, lahat ng mga loadings. Don't forget that. Well, right, of course, hindi pwede nating maisama yung ito, di ba? Hindi yung right support. Posible yan. So, yun, yung first rule, putulin, included lahat dapat. And then next, yung distance ng pinutol nyo na yun would be in terms of x, letter x yun. Okay? And then, do moments, di ba? Clockwise moments, positive, counterclockwise, are negative. Now, let's go and focus dito, mga bis. This will be our moment equation. Now, there is a certain rule which was introduced by Sir William Henry Macaulay, which would help us a bit, no? Malaking tulong to in solving double integration method. Sabi niya, if we have here the value of x, wait, okay, sorry. If we have here x minus a is negative, or since negative lesser than 0, then we could just disregard this term. Okay, so kunwari, if our x value is 3 and our a value is 4, so 3 minus 4 is negative 1. So if that happens, you don't need to include this term. Cancel that out and poof, nawala na siya. Okay, parang ganun lang. Yun yung pinaka-concept niya. So, parang mawawala siya, okay? However, kapag positive naman siya, let's say x minus a is greater than 0, then include that. Or if it's equal to 0, include pa rin that, okay? Yun lang. Kapag less than 0 siya, exclude. Tama ba? Exclude, tama. Tanggalin nyo yung term na yan. Kahit dito, kapag yung x natin dito is naging 7, let's say 7, let's say your x here is 0.5. 0.5 minus 1 is equal to negative 0.5. So, if that happens, tanggalin nyo yan. Don't include that term. Okay? So, yun lang naman po, mga bees. So, I think that's it, no? Na-introduce ko naman kung ano yung mga concept dyan. Oh, no. But ayaw ma-erase. Ayan. Okay? So, ayan. Balik tayo sa formula. Okay, so, that's why double prime is equals to m. Na pakita natin how will we get that moment equation m over EI. Yung EI na yan, most of the times, given yan. Pero kapag hindi naman given, you can always solve for that. Alright. So, ngayon, medyo malabo pa, di ba? So, yun nga, alam natin mahanap yung M, EI. So, masusolve naman natin yung deflection from that. Well, saying pwede na. Pero, let's explain a little bit further with this equation. Okay, so, gawa lang ako ng isang page. Ayan. para mas malinis. Y double prime is equals to M over EI. Right? So, to simplify this further, kapag constant yung cross-section natin, di ba? Kasi kapag constant yung cross-section, well, I is also constant. Pwede natin itong ilipat sa taas. EI is Y times Y double prime is equal to M. Now, Y double prime is the second derivative. And yung sinhanap natin is Y. This Y is the deflection. Kasi kung ito yung beam natin, di ba? And nag-deflection ng ganyan, yung distance from dito papunta dyan, that's the Y. Okay? This distance papunta dyan, that's our Y. And our X value is this. Okay? So, this is the X term and this is the Y term. Now, yung hinahanap natin is Y or the deflection, hindi Y double prime, di ba? So, how will we turn Y double prime into Y? Well, we will do integration. That is why the topic is, double integration method. Okay, so ngayon, how will we do that? So, if we will integrate integrate natin yan, well, EI is constant, so pwede natin lang ilabas. Yung Y double prime natin is magiging Y prime, tama? Is equals to M, but our moment here, magkakaroon yan ng isang arbitrary constant, di ba? Kasi sa integration, kapag nag-integrate tayo, nag-i-include tayo ng arbitrary constant, C plus C1, di ba? Okay, so this, mga bis, ang tawag natin dito, kapag isi-simplify natin, Y prime, ito, itatransfer natin sa kabilang side ng equation, M, C1 over, ibababa nga natin yun, di ba? EI, this will be our slope equation kasi Y prime or the first derivative, this is also equal to dy over dx and is also equal to the slope. So, this term or this equation or the first derivative, we can also call that as our slope equation. Okay, now, continuing further, kailangan ulit natin mag-integrate. Bakit? Kasi nga, we are solving for y. Y prime pa naman to, di ba? So, to solve for that, kapag integrate natin to, labas lang ulit natin yung EI kasi constant rin naman yan. And y prime will be equal to y kasi integrate natin. And dito ulit, mga bis, kapag integrate natin yung moment equation natin, tapos yung C1. So, ito, expect natin that will be C1x, di ba? Magkakaroon ulit tayo dito ng isa pang arbitrary constant, C2. Okay? And if we will simplify this equation, y would be equal to m plus C1x plus C2 divided by EI. Ito, masosolve na natin yung y or the deflection. So, this is what we call the deflection equation. So, both of this equation, the slope equation and the deflection equation is important, no? Para ma-solve natin yung gusto nating puntahan. Kasi remember, no? Meron tayo ditong unknowns, C1 and C2. So, paano natin masosolve yung dalawang yan? Well, to solve for those two arbitrary constant, we will simply need to use boundary conditions. What do I mean by boundary conditions? Let's say, for example, meron tayo ditong simply supported beam, right? Okay, so alam natin that this value is x. Okay, so pwedeng ito yung x mo, pwedeng ganyan, nagva-vary-vary yan. Okay, so if you want to solve your deflection at this value, then set this as your x. Then masosolve yung deflection sa certain point ng beam na to. Okay, so ayan. Erase ko. Now, what do I mean by boundary conditions? At boundary conditions, ano ba yung mga initial na alam na natin dito sa beam na to? Alam natin na at supports, di ba? At support, at this support and at this roller support and at this pin support, alam natin na wala tayong deflection dyan. So, if x is equal to 0 at x is equal to 0, we know that y or the deflection is also equal to 0. So, pwede nating magamit to, substitute natin sa equation na to, para ma-solve yung mga certain, ano tawag dito? Mga certain unknowns, right? So, yan. Ano pa ba? At supports, there are no deflection. And at fixed support also, kapag yung support mo ay fixed, let's say, this is a fixed support, mga bis, no? The slope or the y prime, di ba? Kasi is equal sa dy over dx is also equal to the slope. Yun nga, sabi ko dito. The y prime or the slope at fixed supports is also equal to 0. Okay, so ano pa ba? Yun lang naman. Deflection at supports is equal to 0 and the slope at fixed supports is equal to 0. Yun lang naman. I think yun lang naman yung kailangan natin i-memorize for now. Yeah. Let's just explore later sa mga examples. Baka may mga bago tayong magamit. So, ito yung mga kakailanganan natin para ma-solve tong C1 and C2. So, kapag na-solve na natin yan, well, boom, why na. So, ayun. That's how to do it, guys. Okay? So, ano pa ba? Yan, si Sir William Henrik. Thank you so much, sir. And then, ayan. Where is max def? Ano to? Okay. So, saan? Okay. So, sa isang beam, mga beams, no? The deflection is different per section, di ba? Kunwari, ito yung beam natin. Itong beam natin, nag-deflect yan ng ganyan. Iba-iba yung deflection. Sa point na to, iba yung deflection. Dito, mas mababa. Mas mababa dito. Sorry. Mas mataas dito. Yan. Iba-iba yung deflection natin, mga beast, right? So, how are we going to determine where is the location of the maximum deflection? Okay, so, ang pinaka-main gist dito, mga beast, is it is always, not always pala, most of the times, nasa center. Bakit most of the times? If our beam is symmetrical, the loading is symmetrical, the cross-section is symmetrical, the supports are symmetrical, well, we can say, no, that our maximum deflection occurs dito sa ating center. Sa center mismo ng ating beam. That is when the loading, the geometrical properties are symmetrical. Okay, doon sa sentro. Okay, so meron tayong UDL dyan. Yan, di ba? Symmetrical pa rin naman. Then, tapos meron tayong moment dyan. Symmetrical pa rin yan. It is here. This is the Y max. Okay? Ano pa ba? Pero, kapag okay, next, kapag cantilevered naman siya, yung yung naka-fix lang sa isang support. Kapag ganyan siya, ang maximum deflection natin, no matter what the loading is always dito sa ating endpoint. Okay. Tama. Dito pa rin. Kasi magde-deflect yan parang pag di ba? This is always the Y max. Okay, sa free end. Doon pa rin yung maximum deflection natin. However, kapag asymmetrical siya na beam, na hindi siya cantilevered, yung may dalawang support, kapag ganyan siya, bagabis, the support, no, the maximum deflection is near. It is always near. Malapit yan, pero hindi eksaktong sa sentro. Okay? So, kapag, let's say, meron tayong triangular load dyan, tapos distributed load dito, the maximum deflection, bagabis, it is expected that it will be very near dito sa ating sentro. Pero hindi sa sentro, malapit lang. Okay? So, parang kayo, pero hindi pala. Ganon. Share ko lang. Tapos, ngayon, kapag yun yung case, how are we going to solve sa location ng maximum deflection? Well, there is one thing that we need to know, no, mga bis. The slope, no? This is the slope, right? The slope at this section is pag ganon. The slope here is pag ganyan. The slope dito is pag ganon. Yung tangent line, kumbaga, the slope at the maximum deflection, mga bis, is equal to 0. So, pwede nating magamit yan, that boundary condition wherein our slope is equal to 0 para ma-solve yung maximum deflection. saying, well, for now, it's still very vague and complicated, no? I can feel you guys. Nandun rin ako sa moment na yan noong first time kong inaral to. Pero, tsaga-tsaga lang. More examples, more and more examples will, ayun, English pa kasi ako eh. Pag mas marami example sa mga bisto, mas madali natin itong matututunan. Yun lang naman ang hirap. Okay. So, let's go with this example. Sabi dito, determine the maximum deflection of the semi-supported beam. The beam is made of wood having a modulus elasticity of E. Yun nga. Yung E natin is given as 1.5 times 10 raised to 3 ba yan? 3 KSI or kilopounds. I think, di ba? KSI, kilopounds per square inches. And yung cross-section niya, so, yung base niya daw is 3 inch and yung height niya is equal to 6 inch. Okay? So since base and height yung given, we will need to solve for the I or the moment of inertia. And how will we solve for that? Since symmetrical naman yung section natin, that's gonna be base height cube over 12. So, common na yung formula na yan, di ba? So, multiply na lang natin yan. We will solve for I. Okay? Now, we are solving for the maximum deflection. Okay? So, paano natin isosolve yung maximum deflection? Well, our topic here is double integration method and we will use that. Okay? So, simulan natin sa ating formula. Magandang doon tayo mag-focus muna para makita natin kung ano na yung meron at ano na wala. So, our formula is y double prime is equal to f over ei. And, given na yung ei natin. However, unknown pa rin yung m natin or the moment equation. So, let us solve for that. So, una, ilatag muna natin yung ating beam. Let's draw the free body diagram. Here is a reaction, RA. And here is a reaction, RB. And we have here a 100 pound per feet na distributed load along this 12 feet na beam. Okay. So first, we need to solve for the reactions muna. Okay? Kailangan natin yan. And if you would notice, no, symmetrical naman yan. So, there are a lot of ways to solve for R and RB. And you can choose which one. So, if I will solve this, symmetrical naman siya, di ba? So, ang converted point load nito is 100 pounds times 12. That would be 1,200 pounds, right? And i-distribute mo lang sa dalawa kasi symmetrical naman sila. So, I can say that RA is 600 and RB is also 600 pounds. Alright. Now, with that given, na-solve na natin yung reactions, we can now proceed in solving for the M or the moment equation. Paano yan? Puputulin natin siya dito sa pinakadulo. Pero hindi sa dulo. Pinaka lang. Yung malapit lang. Ayan. So, nang pinutol natin yan, boom. Putol. Now, we have here again yung distributed load nga natin, di ba? Ayan. Tapos, meron tayo ditong reaction, RA, which is 600 pounds and this is 100 pound per feet. Now, this distance, yung pinutol natin is X. Okay? So, that is X distance. Now, let us solve for M. So, let's start here with the reaction na 600 pounds. It will create a clockwise movement, right? So, remember that this is our reference point, pivot point. Kumbaga, iikot siya ganon, magiging clockwise, di ba? So, that would be 600 times. Ano yung distance ng perpendicular distance? Of course, X. Let's proceed. We have here a 100 pound per feet na distributed load. Okay? So, kailangan natin i-convert yan into point load, right? So, para i-convert yan, we will just multiply 100 times kung ano yung length ng beam ng pinag-aakan niya. That would be equal to 100x, di ba? 100 times x. This is 100 times x kasi parang rectangle lang siya. Now, this is negative because it will create counterclockwise. Ikot siyang pag-alan. Now, next, we will also, if, kunwari ito, kasi di ba unknown yung x. So, kapag hinati natin to dito, ano yung magiging distance mula sa centroid ng distributed load papunta sa ating pivot point dito? That would be equal to x over 2, di ba? Kasi this total distance is x. Ibig sabihin, yung sentro ng x na yan is x over 2. Tama? So, divided by x over 2. Okay, so simply say this is our moment equation sa ating formula. So, with that given, we can now solve. Okay? Proceed na tayo sa double integration mismo. So, pagsisulat natin yan, oops, ang taba ng pen na to. Why? Ay, ba't pang tataba ng mga to? Ito. Ngayon, manipis. Y double prime is equals to moment m. Ano yung m natin? Ito nga, di ba? 600x minus, simplify natin to. 100 divided by 2 is 50. X times x is x squared. Okay, so over EI. Yung EI natin, ilagay na lang natin sa kabila para mas malinis. Okay, so first and foremost, integrate natin to. Yan. Integrate natin to in terms of x. Okay, in terms of x. So, ito, magiging yung EI natin, ilabas na lang natin kasi constant naman yan. Diba? So, yung y, magiging y prime is equal yan sa, kapag i-integrate natin to, that would be 600x. Yung, ano tawag dito? Yung initial na exponent natin, mag-add tayo ng 1, plugging plus 1 yan, diba? Power rule ba tawag doon? Basta ganun. Ganun nata. Review na lang integral calculus niya. So, that is 1 time plus 1, magiging 2. And kung ano man yung nilagay natin na exponent nito, we need to divide it here. Divided by 2. Minus ito, 50. That is 2 plus 1. So, magiging 3 over 3. Kung ano exponent nila dito. And remember, we are integrating. So, we will have an arbitrary constant. Let's name that C1. Okay, so here is our first equation or our slope equation. Now, we need to integrate that again kasi nga deflection yung sinusolve natin, right? Y. So, y prime to. Kailangan maging y yan. Yan. So, lagay tayo ng integral sign, no? And ito magiging EI. Yung y prime, magiging y na. Okay. And if we are going to continue integrating this, that will be 600x. 2 plus 1 is 3. Now, meron pa rin yung 2 doon sa baba. Pero yung 3 na yon, ibaba na lang natin. Okay. Minus 50x. 3 plus 1 is 4. And we need to multiply to that 4 plus yung C1, magiging C1x na lang. And then, because we did another integration, we will need to include another arbitrary constant. And that will be C2. Okay. So, okay, again, mga bis, diba? Ito yung ating slope equation, y prime, and y is our deflection equation. Now, pwede na ba tayong mag-solve sa ating maximum deflection? Well, for now, hindi pa. Bakit? We still need to solve our C1 and C2. That's our arbitrary constants. Ano yung value ng mga yan? And how are we going to do that? Again, sabi natin sa ating previous na sinabi, no? Sabi natin, gagamit tayo ng boundary conditions. So, these boundary conditions may differ from every, what do you call this? From every beam to beam. Possible na mag-iba-iba yan. Okay, so tingnan natin. Simulan natin dito sa C1. If we try to look at the C1, ang kadugtong ng C1 is yung ating, what do you call this? Our y prime or our slope. Okay, so we need to find the boundary condition. We need to find a known slope. Okay, and a known x value para mahanap natin yung C1, di ba? Kasi kapag given tong y prime and tong x, then we can solve for C1. If titignan natin mga bis, no, at a pin support and at a roller support, the slope there are not zero, di ba? Kasi yung kapag kapag magdi-deflect kasi to, di ba? Kapag magdi-deflect kanyan yan, the slope here is like that, di ba? So, may slope value yan, may slope value yan. Kapag naka-horizontal kasi yan, mga bis, ibig sabihin, ang slope dyan ay 0. Kapag, and that happens only to a fixed support. Okay, so what are other things? Saan ba yung location dito na alam natin na yung value ng slope niya? Well, if we would try to analyze again, di ba, sabi natin sa ating previous page or previous slide na when we have a symmetrical beam, kung makikita nyo naman symmetrical, di ba? The geometrical properties are uniform, the loading is uniform, and same din yung location ng ating ng ating mga supports. Symmetrical siya. If that's symmetrical, we know where is the location of the maximum deflection, right? So if this is the deflection, mga bis, no, yung maximum deflection will be at the center. That is only true if it is symmetrical, okay? So if it is at the center, this is our y max. And again, what did we tell about y max? At the location of the maximum deflection, the slope is equal to 0. And ano ba yung location ng maximum deflection natin? That is as the center. So, if we can set x, this, okay? This x, diba? Kasi yung x natin, tingnan nyo to. Itong x, namumove yan. Pwede i-move doon, i-move doon. Pwede yan, namumove, okay? So, if this x is equal to 6, then our slope is equal to 0. So, from that, boundary conditions, we can now solve for the value of C1. Diba? Galing, diba? So, now, let's write it here. At x is equal to 6, we know that the slope is equal to 0. So, we will use this slope equation to solve for C1. Now, let us substitute. Okay, so EI times y prime is just the same as slope. Remember that. Is equal to 0. Yun nga, 0. And then, we have here 600 divided by 2 is 300. Simplify lang natin. X squared. Ano ba yung x? 6 squared minus 50. Ano ba yung x ulit? 6 cube divided by 3 plus C1. So, ito, 0 times EI. Well, cancel that out. 0 rin. Therefore, we can now solve for C1. So, solving for that, that is 300 times 6 squared, 1,200. So, C1 is given. Now, okay na yung C1 natin. How about C2? What is the value of C2? The value of C2, we can solve that again using boundary conditions. So, tignan natin dito. Of course, dito na tayo mag-focus, di ba? Sa ating deflection equation kasi wala na mag-C2 dito sa ating slope equation. So, dito na tayo. Ano yung alam natin na known values ng ating y or the deflection? Let it be known ulit, no? 'Di ba? Sabi natin mga bis that at supports there is no deflection, 'di ba? Kapag nag-deflect yan ng ganyan, itong point na to, magre-remain na yan pa rin. Hindi yan bababa. Okay? Walang support settlements. So, ibig sabihin, we know that when our x is equals to 0, then y or the deflection is also equal to 0. Same likewise here. When our x is equal to 12, our y is also equal to 0. It will not deflect. Okay? So, we can use either of the two conditions to solve for the value of C2. Kasi y, meron meron tayong x, meron tayong C1. C2 lang natitira. Okay? So, let's gamitin natin itong 0, 0. Siyempre, mas madali, di ba? So, at x is equal to 0, we know that our deflection y is equal to 0. So, using the deflection equation, substitute na lang natin yan. Ito, EI times 0, kasi nga 0 yung y, di ba? Ito, 0 times ito, magiging 0 rin lang yan. Ito, x is 0, 0 times 50 times ito, 0 din yan. Minus 0. Tapos ito, C1, ang value niyan is 7,200. Pero i-multiply mo sa x, which is 0. So, 0 rin, plus 0, plus C2. Therefore, this 0, C2 is equal to 0. Okay. Now, we can now simplify our deflection equation. Y is equal to, simplify natin to 600 divided by 6 is 100x cube minus 50 divided by 12 is 25 over 12 divided by 2, 6. Diba? Tama. X to the 4th power plus, ang C1 natin is negative pala, sorry. Negative 7,200x plus C2 which is 0. So, never mind. Over EI. Ayan. So, ano ulit yung value ng ating EI? Balik tayo sa taas. Yung E natin is given 1.5 times 10 raised to 3 KSI and our I is base height cube over 12. So, solve muna natin to para minsanan na. Base natin is 3. Height is 6. 6 cube over 12. And that would be 6. Hindi ko kaya. 3 times 6 cube divided by 12. Joke lang. 54. So, that will be 54 inches to the 4th power kasi inches times inches cube. Now, ilagay natin yan sa baba dito. Simplify natin yan. So, 100x cube minus 25 over 6x raised to 4. Ang ingay. Narinig nyo ba yung ingay na yan? Sino yan? May nag-ano kasi sa baba eh. Okay lang. So, ayan. E natin is 1.5 times 10 raised to 3 KSI. And I is equal to 54 square inches. To the 4th power. Now, before we proceed in simplifying this further, take note, no? Tingnan nyo. Dito, mga bisno, yung ginamit natin when we are solving for the moment equation is in pounds and in feet. Okay? And itong EI natin is naka-kilo siya, kilo pounds, tsaka naka-inches pa. So, we need to do unity, no? We need to do unit, anong tawag doon? Basta, yung pare-parehas units. Kapag inches, inches lahat. Kapag feet, feet lahat. Pounds, pounds lahat. Ganon. So, ito, take note na yung dito, naka-pounds siya, naka-feet. So, I suggest, mga bisno, yung i-convert natin is yung nasa denominator, itong EI. Okay? So, i-pattern natin kung ano man yung andito sa baba, sa taas. Okay? So, ito, kung makikita natin, yung KSI kasi, mga bis, diba? KSI is 1,000 pounds per square inch. KSI, diba? So, ito mga bis is equal to 1 KSI. So, pwede nating lagyan to ng conversion unit. Nalagyan. So, 1,000 pounds per square inch is equal to 1 KSI. Para mag-cancel yung KSI doon, tsaka KSI dito. Now, itong inch mga bis, no? So, yung pounds, okay na yan. Na-convert natin. However, itong tama? Itong inch mga bis, no? I-convert natin yan into feet para okay siya, di ba? So, itong inch mga bis, i-convert natin yan sa feet. So, how will we do that? Kapag i-cancel out kasi natin to mga bis, ito magiging square na lang yan, magka-cancel yun, di ba? So, we know that 1 feet is equal to 12 inches. So, ever naka-square yun. So, i-square din natin to. Okay, so yeah, simplify na natin to. We have here 100x cube minus 25 over 6 x to the 4th minus 7,200. Nagbaliktad. Ano nangyari sa utak at kamay ko? X over, ito, 1.5 times 10 raised to 3. Pero meron tayong times 1,000 pa ulit doon. So, magiging raised to 6 na siya. Okay? Tapos, meron tayo dito times 54. Tapos, multiply to 1 over 12 square is 144, diba? Okay. So, yun mga bisno. Ito na yung ating final deflection equation. Ibig sabihin, if you want to solve for deflection, let's say, what is the deflection at this distance or at x is equal to 12. So, ilagay lang natin yung 12 dito. We can solve for the y. So, we can solve the deflection at any location using this equation only. Okay? Palit-palit lang tayo ng value ng x. So, kunwari dito, so, dapat, no, tignan nyo to. Since, di ba, yung boundary conditions natin at x is equal to 0, y equal to 0, same likewise, x 12, y 0. So, kapag pinalitan nyo itong x ng 0 or ng 12, you should have a y of equal to 0. Okay? So, dapat ganun yun. So, you can try it out to prove it. Now, punta na tayo sa tinatanong ng tanong, di ba? Haba-haba ng video na and dito rin pala itong patungo. Ano yung hinahanap? Max def. Where's the maximum deflection? Sabi natin kanina, since this is symmetrical, we know that our maximum deflection will occur here at the very center. Okay? Symmetrical yung geometrical property ng beam, symmetrical yung support, symmetrical yung ating loading. Therefore, sa sentro. So, x is equal to 6, we will have our y max. Okay? So, to solve that, palitan lang natin itong x ng 6. And remember, ang magiging result ng y natin is in feet. Kasi diba ito, kung makita nyo, magka-cancel yung pounds na to, pounds. So, feet yung matitira. Okay? feet, mga bis. So, yung y na to, tama, kasi di ba yung sinasolve natin is deflection, y. So, feet, yung magiging sagot dito. So, substitute lang tayo at x is equal to 6 kasi doon yung location ng max def. 100 times 6 cube minus 25 over 6 times 6 raised to the 4th power minus 7,200 times 6 divided by 1.5. Ito mga bis times yan pala yan. Sorry. I-parenthesis ko na lang para hindi malito. 54. 1 over 144. Okay, yan. Solve natin yan. Yan yung magiging sagot natin na maximum deflection. Okay. So, 100. So, our answer here mga bis is negative 0.048 feet. Okay, so negative mga bis, ibig sabihin our deflection is downwards, pababa siya. Okay? So if that's negative, that only says that our deflection is negative. So kapag positive yan, ibig sabihin yung deflection natin is pataas, umakyat siya. Parang nag-bend siya ng pataas, smile, no, hindi, nag-sad face siya. So kapag smiley siya, negative. Okay? So yun lang yung negative positive dito. And then, kung makikita nyo mga bis, no, mapapansin nyo, it's very little. 0.048 feet. Right? So, that's very minimal. So, kapag nagsusolve din tayo ng in metric to, we expect that that the reflections are in just millimeter, cm, the max, no? Hindi na yan aabot ng meter. Kasi sira na yan. Masisira na yan. So, the reflections are just very minimal. So, ayun. Let's see our final answer. Wait. Naka-inches siya. So, if we convert this into inches, no, we just converting into inches. Paano ba? 1 12-inch is equal to 1 feet. Ayan, times 12 lang. Times 12. Ayun, tama. Negative 0.576. Ayan, same din lang. Naka-inches para yung answer doon. So, ayan mga bis, no? This will be your answer. So, the maximum deflection, ito, 0.048, ito yan. This distance from this point papunta dyan is 0.048 feet or 576. Again, sabi ko, itong negative sign only says that the deflection is downwards. So, pag positive yan, upwards. Okay? So, ayan. I hope it helps you. I'm not sure kung andito pa kayo sa dulo na to, pero sana, medyo may natutunan kayo kahit konti. So, kung medyo magulo pa, we will try another examples, no? Okay, so, ayan, that's it mga bis. If you have some questions in mind, or if you have some clarifications, or siguro may mga mali akong nasabi dito, feel free to comment down below, no? Let's have meaningful discussions para naman na matuto tayong lahat. Okay, so, ayan, that's it mga bis. Please like, share, and subscribe. Muli, ako pa yung Wing na nagpapaalala sa inyo mag-enjoy maglaro manaliksik, maging matinik. Jabi out.